And I saw the agenda for the faith-based leadership.
Oh my gosh, sorry, I pressed go live, so we're going live in a few seconds once it loads.
Okie doke.
Okay, I'm gonna open up the webinar to attendees.
Yes. We are live. I'm sorry for not
Okay,
putting the
no
countdown.
No problem.
This computer works too well.
Yes.
But yeah, the debate was good. We had, I'm actually thinking, you know, maybe we have a left, right, center thing where people come. Oh,
I thought you're the center. Oh, I guess.
all right. Well, welcome to Koviki Talks. And this is a show that talks about all things COVID-19. And there's a lot of shows out there that talk about COVID-19, but this is the only one that will talk about it 100% from the Pacific Islander perspective. So if you haven't figured it out yet, Koviki means COVID. It's a 21 episode series that, again, breaks down all things COVID-19, but we do it from a Pacific Islander perspective. So you will have doctors and researchers and scientists, Pacific Islanders, speaking to Pacific Islanders. So welcome to Koviki Talk. I am one of your hosts, Carl, and Nackie, go ahead and introduce yourself.
Hi, I'm Nackie. Welcome to Koviki Talk. We are on episode 5, Seeking Wisdom 201, with Dr. Andrew Pati-Ayang and Dr. Raynald Samoa. Welcome to Koviki Talk.
Thanks for having us.
Good to see you again.
So it's really part 2 of the last conversation that we had with both of the doctors, and we just didn't get to Dr. Ayang's slides. So let's introduce the doctors once again. If you are new to Koviki Talk, Dr. Andrew Pati-Ayang is a Samoan investigator at the biotechnology company, Dren Bio, where he investigates the underlying cause of various diseases and uses his data to develop innovative and effective treatments. Dr. Ayang was born and raised in the village of Whaleniu in American Samoa. He graduated from Tafuna High School, and received his Bachelor's of Science in Molecular Biology from the University of New Mexico. His discovery of the function of a novel protein complex involved in intracellular communication led to several peer-reviewed publications and earned him a PhD in biological chemistry from UCLA. He then pursued an additional 4 years of research as a postdoctoral fellow at the biotech company Genentech, right in South San Francisco. Awesome, where he identified a novel gene that regulates inflammation in disease models of rheumatoid arthritis and skin allergies. Welcome, Dr. Ayang.
Thank you, Nackie.
Thanks for joining us this evening. Next, we also have Dr. Raynald Samoa. MD is a clinical research endocrinologist. He has a lifelong fascination with obesity-related disorders and has parlayed that interest into research projects investigating the metabolical condition that affects population vulnerable to diabetes, such as Pacific Islanders and cancer survivors. Dr. Raynald Samoa received his medical degree from the University of Washington. He did his adult endocrinology fellowship at the Los Angeles County University of Southern California and his pediatric endocrinology fellowship at Children's Hospital of Los Angeles. Dr. Samoa is the clinical lead for the National Pacific Islander COVID-19 response team. The team is comprised of 10 different regional task forces from around the country and includes states such as California, Washington, Hawaii, Arkansas, Utah, and Arizona. Currently, he is an assistant clinical professor at the City of Hope Medical Center in Duarte, California. Welcome, Dr. Samoa. Oh my God, what a mouthful, huh? I was like, who voted me to do this? That's awesome. We are so proud of you guys. So there you go.
And we're returning. This is a kind of a part 2 from a conversation that we started 2 weeks ago. And it's looking for a cure. And we really didn't get to dig too far into it because we got sidetracked by a lot of questions, which are important. And that's really a big piece of the series is we want to be available. No, let me rephrase that. The doctors want to be available to answer questions. So you can get information, straight from the horse's mouth, so to speak. You're getting them from the people that are on the front line or that are on the bench developing vaccines and all those kind of things. I don't want to get too sidetracked, but since we were together last, President of the United States, Donald Trump, contracted COVID-19. And just briefly, because I know it was one of the first things that I thought about when I heard that he had contracted COVID-19 was the level of care obviously is different for, the most powerful person in the world. But how far is that gap in care that President Trump received versus just your normal person? Is it huge, gigantic, way out of the ballpark, or is it even remotely similar?
So, I mean, ideally, you want to say it's very similar, but there were some things that was used earlier that commonly aren't used in someone with his. So, I don't want to speculate because there's not a lot that was made public about his presenting symptoms, his status. All that was sort of given to us was the indication for starting some of these medications was the fact that he required supplemental oxygen. So I can speak to that in regards to the fact that if somebody requires supplemental oxygen to maintain their oxygenation levels, then steroids are indicated. Remdesivir is also indicated as well. If you require oxygen, and so if you look at it from that standpoint, then it would be very similar. And so that we're hoping that that's kind of how algorithms go. But art is a medicine. Medicine is an art. There are some guidelines that help us sort of form that art, but it's still up to sort of the experience of the provider as to what medication should be used at what time.
Well, thank
I
you.
think adding to that, Ray mentioned that the president received, remdesivir as well as dexamethasone, and these are currently standard of care now for patients who contracted the virus. But these are, as Ray mentioned, these are more for the severe cases of the disease, stage of the disease. Is that correct, Ray? But then I think the president also received a cocktail of antibodies, I believe, and this is currently in clinical trials. So that's something that's not currently available.
I think there's Regeneron.
Yeah, this is from Regeneron, I believe. And you asked about a gap, right? So I think that's the gap, right? Like he's the president, so he could have access to something like this. Whereas, this has to go through clinical trials, and that trial has to be completed in order for, the wider public to start getting that type of medication. Right?
Yeah.
Well, I appreciate you both taking the time to do that. And then I'll let Dr. Young take us back to where we left off 2 weeks ago. But yeah, that's the first thing I saw that I wrote it down. I'm like, I'm going to ask that as soon as we get back on with the doctors and find out just how different the level of care was. So I appreciate it.
Right.
So can you see my screen?
We can.
So again, Koviki Talk, Seeking a Cure. And so last time I mentioned some statistics and numbers of, cases and deaths. We didn't get into the actual focus of seeking a cure. And what I mean is, in this presentation, I'll cover some of the, how some of the drugs are developed and the basis for those drugs. And this is really due to efforts of scientists and physicians and better understandings for the basic biology of the virus in order to come up with like the best drug to target to be used as a treatment. So I want to start again by highlighting so this is what I showed. I think we had our first session on about 2 weeks ago, I believe. And so these are the numbers then, September 27. So globally, close to 33 million confirmed cases, close to 1 million deaths. And then you can see here the number of cases and deaths in the US. So as of yesterday, right? Yesterday is the 11th. So as of yesterday, sorry, there's a typo here. But this has gone up to 1 million deaths now. So we've surpassed 1 million deaths globally. And in the US, so 2 weeks ago, 202,000 deaths. Now it's 212, going to 213,000. So the numbers are still increasing. And that's why, we're pushing for people to social distance, but also wear a mask, while clinical trials for vaccines and also other therapeutics are currently undergoing.
So question, Dr. Young, did we ever get out of the first wave? We had always talked about a possible second wave in the winter. Numbers are still going up. Have we ever really gotten out of the quote first wave, or are we still mired in that?
I think we're in, maybe Ray can speak to that. I think we're going in the second wave now, right?
It's really hard to say, because there wasn't really a dip.
Mhm.
It was a plateauing and a continuing.
Yeah.
So a real wave comes from, it's an ebb and flow, right? So the ebb has not really manifested itself. So, I don't think you'd be wrong to say either way that this is the extended first wave, or, say it's the second wave, because it's semantics. Both of them are saying that we're still in the midst of a pandemic.
Great point. Well, good way to put it. We're still in a pandemic.
Yeah, we're still, and the numbers are still rising. Do you think because now they're starting to open? Well, I know restaurants are open now, and hair salons and just things are starting to open. Do you believe the numbers will start to rise?
I don't know in terms of, for the 2 weeks data that I've shown, I haven't seen, earlier data and seeing what the rate of increases, but this is an increase, right? So, but now that a lot of the mandates are slowly easing, so I do expect a further increase.
Yeah, the criteria for opening is very murky. There are some really promising tools that people are using to decide whether or not a place is safe to open up more. I think the California Department of Public Health, they have a vulnerability index, and part of their charge is to make sure that the people that have the highest risk, which oftentimes are communities of color, if they do not show an improvement in their rates and numbers and impact, then that area is deemed not ready to open. So, the problem with those types of, which I applaud fully, the problem we're having from a Pacific Islander perspective is that the data that's used to say we're under better control is not, it's, I don't know how accurate it is, and I don't really know how, there's not really any assessment that's available right now that talks about the presence of protective factors, like what things that commonly are protective of a community, like how safe are people to stay home? Like, if you're about to lose your utility because you can't go to work, you're not as safe, right? Because you're going to be forced to go out and do things to try to gain money, if you have to deal with those types of stresses at home. So those types of things need to be assessed to see how safe are people really. And luckily for us, there's a NHPI survey that's being circulated right now, because I think we've reached at this time we've reached the understanding that there are some things no one's going to do for us, and that this retrieval of information, because we're a community that's very difficult for epidemiologists, and researchers to evaluate, because statistically it's difficult for them to apply our community to any of their models, you know. We're basically statistically invisible. So, we decade after decade, we've been kind of told this. And we've realized that this pandemic was our chance to finally say, that's no longer an excuse. If you're not going to do it, then we're going to do it. We're going to figure out a way to obtain that information, and engage our communities, so that their needs are assessed and communicated.
I think also an interesting number would be, restaurants are opening, but if, people are allowed to go out and, to restaurants, but still maintain social distancing and wearing masks, I think it would be interesting to look at that versus going out and not wearing your mask or not social distancing properly. I think it's going to be a very different observation.
But I have to tell you, so there's restaurants in our neighborhood that have kind of moved the dining to outside, and so they have people sort of separated to some degree. I have to tell you, right? And the biggest problem is that, none of these diners or patrons are wearing a mask. So, because it's too difficult to pull your mask away if you're chewing. So I guess they just don't feel the need to wear a mask. So you're in this space where you're eating and there's people walking by because the streets are full now. So that social distancing, although it's like theoretically happening between them and the next diner, it's not happening for the street. Like it's I don't know. I mean, like, it's sort of at this point, I see people so frustrated and tired that we're just kind of going through motions now. And I think we have to be very careful about that.
Right.
Okay, so let me continue. So again, this is just showing what's currently in preclinical as well as clinical trials. So this is from last, 2 weeks ago, and these are the numbers now. So there's an increase in sort of preclinical studies, but what's really the number that we should focus on is in the approved cases, there's still none, right? So the two trials that I've been following are the Pfizer and the Moderna trials. And I saw in a press release from Pfizer is that they're actually starting to report data from their clinical trial by the end of this month. So that's exciting for me, but I think it's also exciting for all of us who are anticipating a cure. So,
Pati, was that like a 1 month from first inoculation? Is that like a 1 month analysis?
yes, yeah. So I don't know if they would have already had there's going to be 2 shots, right? So I think this will be post that, yeah. But for both, both trials started with the goal of recruiting 30,000 volunteers for either study. And for Pfizer, they increased this number to 44,000. And one of the reasons is to increase sort of diversity in the makeup of the trial. So, older people, minorities, I think also younger, children are also now considered. This was on their press release, but I don't know exactly whether this is going to be, whether they're actively recruiting teenagers for this. So this is where we stopped the last time, and as you guys mentioned earlier, this is the focus of this podcast is seeking a cure for COVID-19, and so we wanted to go over sort of the biology behind the infection, but also how researchers are using this information to develop cures. And so what I'm showing here are our immune system. We respond in 2 ways when there's an infection. And so the first response, and if you have any questions, feel free to ask. And Ray, you're welcome to chime in anytime. So the first response is really the innate immune response, and this is when you have the initial infection. So you have a pathogen here, and you can imagine that this is the coronavirus. So cells in our body have these proteins on the surface, so receptors that can recognize the pathogen. And when they recognize the pathogen, the cells start to secrete, molecules like cytokines and interferons. And these play, you probably have heard of like this cytokine storm that has, affected a lot of the severe cases of COVID-19 are as a result of a cytokine storm. So the innate immune cells are just overproducing these cytokines, and this triggers sort of inflammation. So it's hard for sort of the balance is really in sort of this active inflammatory state, that it's hard for the body to sort of like maintain balance. And that's why there's cells are being recruited to the lungs. It affects breathing. And so when these cytokines are released, right, so this is a signal to neighboring cells that haven't been infected to tell them, okay, there's a pathogen, so get ready, protect yourself. This is also a signal to cells that have been infected to commit suicide, so to kill themselves such that the virus doesn't, spread to other cells. But these cytokines, they also play a role in, it's a signal that's sent out to immune cells. And these are the cells that sort of patrol and protect our bodies. So it's a signal from, non-immune cells to immune cells to say, hey, there's an infection, please come help. So now you have neutrophils, macrophages, all these types of innate immune cells that come to try to first battle the infection.
So what we're looking at is this is a good response to,
yes.
This is a healthy response to the pathogen.
Yeah, so this is this is a natural response, right? But when you say healthy, that really depends on the pathogen, right? So and how that pathogen, so how SARS-CoV-2 induces this initial response, right? So it can be healthy if the body can maintain, a balance where it's not, there's not too much that, you get a high fever or you start to have, start to affect your organs. So that's not a healthy response. And I think a lot of patients with COVID-19, the response is quite severe, right? And that's because the body is not able to control the signals, inflammatory signals that are being sent to different cells in different parts of the body. But you know, this type of information that researchers and physicians are looking into, this, you know, helps. Are there medicines that are already approved for other things, right, for other diseases? And depending on what we learn from, you know, from patients' response, can those medicines be used? And what's great about those medicines is that they've already been approved, right? So they've already gone through sort of the safety trials. We know that they're effective. But again, COVID-19 is a completely different, it's a completely new disease, right? So just because we have, you know, existing medicine doesn't necessarily mean that those can work for COVID-19.
So would that be, oh, go ahead, Nackie.
Oh, so if you have a compromised immune system, so like you said, when the COVID-19 gets into your body and it somewhere they let the other cells know that, hey, it's time to fight, and then the ones that are bad just die off. If your immune system is already compromised, you've already got cells that can't fight, so you're more likely to get sicker or, you know, ill, fatally ill, right? So that's why we're saying if you have a compromised immune system, it's more likely for you to
have a severe case.
Right.
That's a very good point. You know, people who've undergone chemo, right? So their immune cells are compromised. So they're not as, you know, because essentially that kills your immune cells. So they're not as robust as they as like a healthy person, right? And those are the cells that you really need to try to clear the virus. And this is why, you know, there's, just because you're not having symptoms, you're asymptomatic, you can still infect people. But importantly, you can infect those who are immunocompromised, and those people, those patients can, their response will be very different than a healthy person. So they'll get sicker.
So that goes with, you know, like we're saying the numbers in Pacific Islanders are so high, but that's also because our numbers are high in diabetes, so that affects your immune system. Like it would even gout and, you know, like just every disease that you can think of that a Pacific Islander is most likely, heart disease, anything like that, which we usually are, you know. Obesity is a big problem, diabetes, that gives us a higher risk, right? Okay.
Yeah, I believe so. Yeah.
Right. Yeah, because there's this immune system that we have. It's kind of like when, you know, the optimal immune system. It's dependent on everything else working fine, you know. So if you have something wrong with another part of the engine, it may not affect it. It may not stop this from happening, but it'll make it harder for it to work.
Right. Yeah, I think that's huge for our community to understand, you know, that just because you feel fine, but if you're diabetic and you're not taking care of yourself, the chances of you fatally getting ill with COVID-19 is very high. And the elders also, right? I just want to get that out there so we understand that our immune system plays a big part of COVID-19.
Exactly. Yeah. So I'm actually, you know, a question for Ray. Have you seen any COVID patients who are sort of, you know, also diabetic, and whether you prescribed any of, you know, medicines that exist for their symptoms? Or
so, you know, with our patients with diabetes, we know that it's you sort of have to weigh the benefit of the medication to its risks. So with somebody who has COVID symptoms, or has been diagnosed with COVID and starts to have respiratory symptoms, these patients now, you know, the usual thing is people start steroids because it's indicated. Steroids will make your blood sugars go up, you know, and so and sometimes it goes up significantly. So there's a lot of like coordination that has to happen.
I see.
But when you treat one condition, forsake the other. So another reason why you need to see your doctor sooner rather than later if you're manifesting symptoms, you know, because Carl had a very interesting point, like, you know, it's not so much, so this is the normal immune response. This is what's supposed to happen, but it's how strong the immune responds to the antigen that can cause some of the problems that lead to death with COVID-19. So one of the cascades that can be activated by the immune system is this what we call our clotting cascade. So there's a fine balance in our blood between things that can stop our blood with, you know, by forming clots, and things that help it run smoothly. So when the immune system is overactive, what you can have is like spontaneous clots happening. And clots can cause a blockage of blood flow to certain areas. And so one of the things that can happen with COVID-19 is that you can get these clots all over your body, you know, and if they block the blood flow to your liver, your heart, you know, your brain, it can cause significant damage, you know, and into the liver, I mean, to the lung as well. So that's a way where the immune system is working and responding, but it's over responding, which can lead to, you know, death as well. So it's important to know that what the manifestations are. You don't really need to know how it happens, but you need to know some of these that it can manifest in different ways when they're ill. So, you know, you've heard people talk about for those of you who've had a family member that's been really ill from COVID, you may have had a discussion with physicians about kidney failure. And that's one of the mechanisms of kidney failure. So there are numerous times people reach out to me. You know, you've heard people talk about so it's not an unheard of thing for people to go on dialysis when they have COVID.
So, you know, it's interesting that Ray brought up, you know, the clotting cascade, right? Because this is one of, you know, for patients who've had severe COVID-19, right? There's a lot of fibrosis in the lungs. And so what happens is that this is permanent, right? So just because you get better, right? So, you know, you clear the virus, you no longer have COVID-19, you have this permanent damage now to your lungs, to your organs. So that's going to affect you for the rest of your life. So any exertion that you do when you walk, you're going to have, you know, people are going to have difficulty breathing, exercising. So it's really going to change your lifestyle.
Wow.
Yeah, that's how the steroids work. Because steroids, they suppress the immune system. So the steroids kind of suppress that overreaction by the immune system, which I think is what's helping with COVID-19. So although steroids is the medication that's discussed the most and is most often used, there are actually other medications that suppress the immune system that show promise in regards to sort of halting this process. So, you know, you may see clinical trials happening with some of these other immunosuppressants. You know, like one particular population, which was very interesting, are cancer survivors who went through stem cell transplant. They're on a whole host of immune suppressants because, you know, they're trying to protect their stem cells from their immune system attacking it. So we thought in the beginning that they would be, you know, that if they could develop COVID-19, that they would really progress really quickly. But some of them, you know, and mind you, you have to do research to validate these outcomes, is that some of them didn't get any symptoms, you know. And so when they got COVID. So that's why researchers are now looking at some other immunosuppressants to see how effective they may be.
Okay.
Okay, so that's the, you know, that's the first response is the innate response, and then there's the adaptive immune response, and this is where, you know, this is where B cells and T cells come into play. And so this is our body's natural drug, right? So the cells that first get infected, they would go to the lymph node, and there they activate B cells, and B cells are the ones that start to produce antibodies that may be specific to whatever pathogen infected you. And the antibodies themselves, I don't know, you guys have probably heard of neutralizing antibodies, right, as a potential drug. So these antibodies can recognize the pathogen, so they can recognize SARS-CoV-2. They bind it, and that blocks SARS-CoV-2 from going into our cells and infecting our cells. Okay, so our body is starting to produce these antibodies to prevent that infection from happening. You know, other cells that are important are these T cells. And T cells will specifically recognize cells that have been infected. So when a cell gets infected, they start to present, you know, they have these markers on them. And basically, it's like a SOS signals that says, I'm infected. So the T cells see this, and then they attack those cells. So they kill those cells to prevent the infection from happening. So this is the idea behind vaccination, right? So vaccination, the point of vaccination is to trick our system into having our B cells produce these antibodies, but also having our T cells to like basically prime them to get ready for the actual infection from happening. So when you get vaccinated, you're gonna have antibodies against SARS-CoV-2. So when you do get infected by SARS-CoV-2, we already have those antibodies that can directly prevent this, you know, the virus from getting into the cells infecting, but also we'll have T cells that will be essentially ready to kill any cell that gets infected.
So when we hear that that people tested and then they found the antibodies, these will remain in the body after and are identifiable to the test, that these are the ones that fought COVID specifically? Is that when they say they see antibodies as a test result? Is that what they're seeing?
So yes, exactly. So, you know, when you get infected, again, you're going to produce these antibodies. And so what they do is, you know, when they have these serological tests, right? So they would have an actual SARS-CoV-2 viral particle. And if the antibody in the test can bind, then that means that, you know, the body has produced antibodies against the virus, right? So that's how you know, it's a test whether you're positive for infection because you have antibodies that were developed to bind the virus, yeah. And those antibodies can be neutralizing antibodies. So they can act as blocking agent that blocks the virus from getting into your cells.
So once you've had COVID-19, you cannot get it again, or we don't know?
We don't know. So there's when you introduce an antigen to your immune system, how how good the antigen is at stimulating our immune system every time, it varies, right? And so you often hear COVID-19 described as a novel virus, which means it's relatively new, or the strain is relatively new. So we don't know how strong it's what we call our immunogenic, or how well it stimulates our immune system every time, or how long this immune response lasts. Because we only have 6 months. If you include like the data from Asia, we have about 10 months of knowing what the immune response is. And so that's not much time to know, like, if you can catch it again. There is one, I know there's some isolated cases of people testing positive again after, 3 months, but those aren't very common.
And if you're a carrier of COVID, like you don't get the symptoms, but you get tested and you're tested positive, are you always a carrier, or you just have to stay quarantined for 4 days and then you're no longer a carrier? How does that work?
So
So you're
carriers are people that have the actual virus,
Mm,
and they can shed it.
right.
And so they're how long that the virus lasts is variable. What they're not doing, though, is they're not showing significant symptoms based on their immune response to the virus. So there is still question about how strong the immune response is from asymptomatic carriers. We're still trying to figure out, like, how well one responds to it when they see it later, and once they clear it, once their immune system gets it out, they're no longer a carrier.
Okay.
So the virus is gone, but if if the body sees the virus again, right? So that's the beauty of the adaptive response. This adaptive immune response is that these B cells and T cells, they retain memory. So they will remember that you had a previous infection, so they already know what to do.
Oh,
Yeah.
well, that makes sense.
Well, that's the whole that's the logic behind a vaccine.
Right.
But there are viruses like influenza, right? The flu, you have to seasonally get vaccinated, right?
Right.
And then there's all, that brings into the subject of mutation. So some viruses, they mutate very fast, that they sort of change some features. So then the body, it had memory for the previous feature, but now it looks slightly different. So you have to, basically you're starting your response again, because
Okay.
it's slightly different. Yeah.
Wow.
And so, yeah, so this is what I showed earlier. You have your T cells that will recognize, cells that are infected, and then they kill them. And then you have your B cells, they secrete these antibodies, and the antibodies, they bind virus particles that are in circulation and block it from getting into the cell. So at the end of this, we're gonna play a little game, and basically, and this is the type of information that researchers and physicians do. We really want to understand, first, what does the virus look like, right? So SARS-CoV-2, it has this spike protein that forms, it has three, like a trimer, so you have three particles that form a complex. And so when we know this type of information, we also know what type of, molecules that we can develop that can specifically recognize, oh, okay, this looks like SARS-CoV-2 spike protein. And so, and this is what, researchers call structural biologists. So they know exactly the atomic resolution, or the true features of the spike protein. And this is, this is structure solved by a method called crystallography. So this was my training when I was doing my PhD. I was a crystallographer. So my work was looking at identifying what exactly do proteins look like at the molecular level. And so, so we want to know, what does SARS-CoV-2 look like? So what are the proteins that coat the cell? We also want to know sort of biology. How does, different viruses can infect cells differently? So for SARS-CoV-2, in order for the virus to infect a host cell, it has to specifically recognize this receptor, or this is a protein that's displayed on a host cell, and this is called ACE2. And the spike protein on the virus specifically had to recognize ACE2, bind, and this forces the virus to invade the cell. And so, based on this information, right? So, okay, so that's the first step is the virus, it recognizes the cell and it binds ACE2. And once it binds, it internalizes. So the virus gets taken up. And then the virus, it releases its genetic material into the cell. And once it gets into the cell, this is when it starts to reproduce. So it makes a lot of copies of itself, and then eventually the cell explodes. So it explodes and it releases many different copies of the virus. And those particles, they go on and they infect the next cell. Okay, and this process continues. In the meantime, the immune system is trying to slow that process down, try to, stop that from happening. So this is the type of, so when you're thinking about how can I stop this process from happening, there are many different ways that researchers look at how to develop a drug, right? So the first is really, okay, so this is where we come into the game, right? So let's, so based on this information, right, like I've shown you that the SARS-CoV-2 particle enters the cell by binding this receptor called ACE2, right? So based on this information, so Nackie and Carl, what would you guys suggest? How would you develop a drug? What kind of drug would you develop to stop the infection? So I can start, right? So one strategy that people are using is that they're developing molecules that can block the receptor, okay? So that can bind the ACE2, it blocks it. So now the virus cannot bind the ACE2, right? Because there's something that's already protecting it.
Oh, so I would say that you would make a drug that would not
block
let it.
the
So what kind of drug would you design, right, to cure COVID-19? So it's really once you understand the pieces of the biology,
Right.
it's ideas start to come into your head, right? So once we know now that it needs ACE2 to get into the cell. So hey, let's develop some molecules that can block ACE2. Okay, so that's one strategy, and this is something that's happening, that's already happening. So in the preclinical stage of research, this is where all of these different types of ideas are happening. So scientists are looking for antibodies that can bind ACE2. And this can, prevent the interaction of the ACE2 with the virus.
How about a drug?
Huh?
Oh, I'm sorry. I was going to suggest a different one, but go ahead.
Yeah, no. I was going to ask, do you have another one?
One that would let the T cell recognize that it needs to be, that it's visible to the T cells.
Yeah. So that's the natural drug, right? That's the drug that our body makes. Is it makes these T cells that can directly see the. So I think what you're saying is to make these infected cells more, more accessible to T cells, right? That's.
Sure, that's what I meant.
No. I mean, that makes sense too, right? Because oftentimes these viruses, they develop very tricky ways to try to evade our immune system. And part of the one way to do that is by preventing, by avoiding the display of their material on the surface of the cell. So by preventing that, the T cells cannot see it, so they cannot attack it, right? So it's really complicated, but also very fascinating.
So by blocking the ACE2 receptor, would it just die off because it can't hook on to the ACE2?
Like, so the virus has to infect in order to reproduce, right? So if it cannot go in because you block ACE2, then the virus eventually will be clear.
Oh, okay. It will just die out, right?
Yeah. So another strategy, right? So the first one, we're blocking ACE2 on the side of our cells. The second way is to develop molecules that block the spike protein, right? So the spike that recognizes ACE2, if you have molecules that bind that, then it's not going to bind ACE2. So that's another way. And so I think this is the strategy that's actually being actively pursued by researchers. So what they're doing is, our bodies can, it sees the virus, right? Especially the spike protein. So it makes antibodies, and these antibodies bind the spike protein. And by binding that, the spike protein cannot bind ACE2. And that's the idea behind neutralizing antibodies.
That makes so much sense to me. Like,
You can get us to
so
understand
awesome.
it. You're a really smart guy.
So awesome.
It's cool, right?
Yeah,
But like,
very cool.
this is why I had some great teachers in college and grad school who introduced these concepts this way. It's like a game, right? It's like a video game. Like, how do you block this and this? But now it's a video game with for medicine. Right. So, and once you know sort of the basic biology, how the virus infects, you can start to come up, with a list of like, okay, how can I do this? How can I do that? And again, that's just the first stage, right? That's the very first stage where you have the first interaction of the virus with the cell. But then once the virus gets in, right, all our ACE2 blockers, those don't work anymore because now the virus is inside.
Right.
So once the virus is inside, then we have to, okay, what's our new strategy, right? So what can we, what kind of drugs can we make to target what's inside, what's going on inside the cell? And this is the idea behind the drug remdesivir.
So remdesivir was already, that didn't get created for COVID-19 specifically. It was a drug that was already created that just happened to work with COVID-19?
So it was created for Ebola. Ebola and SARS-CoV-2, they have a similar, protein, like this viral polymerase. So can you guys see my mouse?
Yep.
Yeah.
So Ebola has a similar protein, right? And so the function of this protein is basically to help the virus reproduce.
Gotcha.
Replicate. And so what remdesivir does is it pretends like it pretends like a nucleotide, and it binds this viral polymerase, and then it blocks it from functioning. And so you've got me actually interested in this stuff, and I never thought that I would be. We're going to take a quick station identification break. We got a guest we got to get in, but I've never thought I would be wondering about RNA.
I love this because I get it now, and
I'm glad we're getting along. So real quick, you are listening to Koviki Talk. It is all things COVID-19 from a Pacific Islander perspective. It's brought to you by Patient-Centered Outcomes Research Institute, or PICOPSI, and Pacific Islander Center of Primary Care Excellence, and that's PICORI. Right now, we're going to bring in Rita Satini, and she's a member of PICOPSI, of the Policy Council. So let's go ahead and bring Rita in, and she's going to talk to us about, I believe, the week of action, and then we're going to get back to RNA.
Yes. Thank you so much for having me, Koviki Talk. I'm really honored to be here. I am the co-chair with Joseph Saia over the policy group under PICOPSI. And this week, starting today, we just kicked off our PICOPSI Native Hawaiian Pacific Islander voter registration week of action. So today we are celebrating Pacifica and Indigenous solidarity. Tomorrow will be about COFA health justice. Wednesday's my day. I'll be talking about Pacifica climate justice. Thursday we'll be talking about the Pacifica youth voice, and then we will close out the voter registration week of action with the state of Pacifica, kind of like the state of the union, but it'll be about the state of Pacifica. And really, the goal is to urge our community members to vote, because our vote impacts each of these different themes, and those themes impact our very lives. So each day will at 6 o'clock, right now we actually have a panel going on, but every single day, 6 p.m. Mountain Standard Time, 5 p.m. Pacific Standard Time, PICOPSI will host a panel for each of these days. But throughout the day, each day has been assigned to different organizations throughout the nation, and they'll be sharing information that has to do with COFA, Pacifica, Native Solidarity. I'll be sharing a bunch of information that has to do with Pacifica climate justice through Wednesday. But really, and then we'll just be pushing people to pacificavote.org to register to vote, to check on their registration, to ask for a ballot, absentee ballot. But really the whole purpose of this whole week really is to get our people civically engaged. And that first step is registering to vote, familiarizing themselves with who the candidates are, what the issues are that are on the line this election year. So thank you again for the opportunity, and I'm just glad to be here to share that information.
Thank you, Rita. So important to get everybody out there and vote. And it's a huge operation. There's so many different people involved. Can you just real briefly talk about how this whole concept came up, week of action, and then maybe some of the players behind it? Because I know there's a big effort behind this push you're making this week.
Definitely, we have. So again, Joseph Saia and myself are the co-chair of the policy team, but the brains behind this whole operation PICOPSI would be Dr. Samoa and Dr. Nia. Those two, along with ourselves, and we've got Utopia, Epic. Epic has been very instrumental. Pikawa, and then of course UPASEC, which is the coalition that I am the executive director over. We all came together. We recognized that this is really a very crucial, vital election year. And more than anything, our people, a lot of the benefits that we are dependent on are on the line. So, protecting our pre-existing conditions, marriage equality, many of the regulations that are being threatened to protect us at an environmental level. All these things are on the line, and every single one of these things impact us as a community. So these are all the people that have participated. If I'm missing anyone, Tavai, Dr. Ray, Dr. Nia, please jump in and let me know. But, we've got a very solid group. I'm very proud to be a part of PICOPSI. We're doing some things that, has never been done before. We are demanding a seat at the federal level at the table. And we want to make sure that we have representation at all levels, fighting for us and championing the causes that are important to us. And the only way that this is going to happen is that when everyone registers to vote. Step one, the most basic step of being civically engaged, is registering to vote. Step two, familiarize with the issues. Step three, get involved. Step four, there's all these little steps that you can take that can help, change and bring to pass the world that you're reimagining for yourself, for your family, for your community.
That's awesome. Thank you, Rita.
Thank you.
Thank you, Rita. Okay, we are back to Dr. Young, and I'm actually, I gotta give my wife is a genetics, she's got a genetics degree. So I'm gonna tell her that I was on a show where I was actually looking forward to coming back to going over RNA genomes. And I truly am. This is, you're a really smart guy when you can get Nackie and I to understand this kind of stuff. So
Yeah.
stage is yours.
That's hard to do. That's hard to do.
I've had some practice. My mom is staying with me for the moment, so she's always asking about what I'm doing, so I have to break it down for her. But yeah, this is actually the last slide, highlighting remdesivir. And this is a drug that blocks another step of the infection process, right? So it was a drug that was designed for Ebola, because Ebola has a similar, polymerase to SARS-CoV-2. And by blocking, the polymerase, you prevent the virus from reproducing and furthering, and so preventing the infection that way. And as you can see from the slide, the viral life cycle, it's a very complicated process. And there are many different steps that we could potentially make drugs for. So really the bottleneck is the funding to, it's getting people, researchers being interested in topics like this, but also, getting the funding to finance these types of discoveries.
So are there companies that in your chart, are there companies that specifically look at different links in the chain? That is there a certain company that just specifies particularly on like number 8, formation of mature virion? Is that
no?
Is there?
Yeah.
Or do they? No, every company does all of them.
So the answer is no. And the thing with biotech companies is that they really like what's trendy, right? What is trendy, and there's also a profit side to biotechnology, right? And right now COVID-19 is super trendy, right? So everyone wants to get in, but also everyone wants to help out too, because it's affecting all of our lives. It's affecting companies as well. So if people are sick, they cannot come to work. So we essentially halt our economy. But to answer your question, a lot of the basic research and understanding all of these different steps, this is actually being done at the university. So professors, this is what they're, Ray as well is doing a lot of basic research at his university. So the professors are the ones that really try to figure out biology. And, the biotech, they're the ones who take that information and make drugs based on that information. Because it takes a long time to identify all the different steps. So it's difficult to sort of do drug discovery at the same time you're trying to do the basic discovery. Some companies do that really well. So Genentech, where I did my postdoc, they do both. They do the basic discovery, but also the drug discovery based on their findings from sort of the basic side. But companies like Gilead, right? I feel like Gilead is one of the main ones that had always a strong focus on viruses. So that's, they had remdesivir ready because they had that program for Ebola. But many companies don't even study viruses. Yeah. Right. So, they study cancer or, all of these different diseases require a lot of time and, effort and brain power as well as money. So you can't do all of these things, no matter how interesting these things are.
Should we go to the chat?
Yeah.
Yeah,
It looks like there'll be some interesting comments from the chat room.
Did you want to, let's see. Rebecca Delafield, she says, thank you so much for presenting today. Please clarify for the audience about what to do if you test positive for COVID, but are asymptomatic. I think that the CDC recommends isolation versus quarantine for people who are asymptomatic and have a positive COVID-19 test for 10 days, not 4 days, since the last positive COVID-19 test. Isolation could be ended earlier if you have access to repeat testing, 2 negatives within 24 hours.
I think Dr. Delafield was making a comment more than a question.
Yeah, I know. I was like, that's
That sounds like an answer to the question.
right.
No, Becky's
Yeah,
right.
that's
You
it.
have to you have to isolate because you still can infect other people if you're not manifesting symptoms. In fact, they would be probably the best transmitters of the virus because there's no reason for people to think that they have to avoid them. So those are the people that need to wear masks. Because remember, masks are so at protecting you from getting it. What
Right.
it does really well, though, is keep you from transmitting it. And then, yeah, if you do test positive, you should be under quarantine until, you know, you're after 10 days, or if you, because it used to be 14 days, but now you can do 10 days, or you can get tested twice. I think several of my friends got tested after 6 days and were found to be negative. So, and then they got another test, and then they were cleared from their quarantine. So
So yeah, so I think we have a question that Savai sent
Yeah.
out. So this is from an anonymous attendee.
Mhm.
The question is about, do you think that finding an effective treatment for COVID-19 will be more important than finding an effective vaccine? So the short answer is that both are happening simultaneously at this point. So therapeutics are being investigated as well as vaccines. I mean, vaccine is more, not permanent, but like a long-term solution, right? Because once you're vaccinated, then you essentially allow your body to defeat the virus. Whereas for non-vaccine type drugs like therapeutics, they can act immediately, to slow down sort of the inflammation, like using these steroids, or also, can block the virus from further infecting other cells, like the antibodies that we were talking about. So those both are happening simultaneously at the moment.
but there are very few antiviral drugs that are developed, in specifically for a certain virus. There are very few exceptions that you can count on one hand, like HIV. So the HIV virus has been around long enough where they were able to do treatment testing over a period of years and continuously develop new drugs for the virus. It's a special type of virus that keeps mutating, and so the treatment had to sort of match what the virus could do. But yeah, there's just not a lot of drugs aimed at viruses, especially ones that like occur during a pandemic, which is why we don't have a flu medicine. We have a flu vaccine because it's just really difficult to find a medication that can treat a particular virus. There were other questions, right?
There was a question from Ellen Tyrell, she's talking about the people. I think we were going to do a show about the people that are stranded here from American Samoa or Samoa, because the borders in Samoa are shut down. And I think Dr. Ayang, we discussed about doing a show, but they're asking a question. They're at
Oh,
the current, go ahead, Carl.
so she's asking specifically, would you both be willing to do a Zoom forum that would involve gubernatorial candidates from American Samoa? The current administration won't repatriate the 500 plus stranded residents until a vaccine is produced. So I think they're looking for to get people to the table to talk about it. And the people that the group that we were talking about that can't return to American Samoa. And then there was a second question that she asked, how hopeful are we with really getting a vaccine as early as January, or for the general population to get a vaccine?
I think it's looking pretty good, right, Bucky? I mean, like, granted, you don't know how these tests are going to end up, but if they're doing like their 1 month analysis now, they'll probably, I can foresee a vaccine being ready for distribution by January. Now, that being said, I don't know if it'll work, because
Right.
remember, it takes time to see how well a vaccine, how, the immunogenicity of a vaccine. So, that just because a vaccine is available, I'm not sure people should bank their public health policy entirely on the availability of a vaccine. And so, as far as like joining a Zoom forum with the gubernatorial candidates, that's above my pay grade.
Right. I know.
That's a Nia Aito'oto kind of.
I think it depends also whether they would be interested in talking with us.
Yeah.
Right.
But yeah, if Ray does it, then maybe I can, I'll just tag along. I'll tag
No
along.
pressure, though. No pressure.
It's called
Pressure.
passing the buck.
Yeah.
Passing the buck. Go ahead.
There's a question on Facebook. Could you speak to SARS-CoV-2 overload? What do we know in terms of high extended exposure to COVID and the correlation to a severe systematic response, including death? And then 2, in the 10 months of international data available, do we have any early retrospective data to show any early signs of mutations to the SARS-CoV-2 virus?
I'll take the first one, and I'll take the second one.
Sure. So the first one, remind me, could you speak to SARS-CoV-2 overload? So I think way back when, early in the pandemic, Nackie and Carl and I talked about the concept of viral load, So what was done by a lot of indigenous people early, very, very early on, was they would take small parts of secretions from somebody that had an illness. So like a little bit of saliva, or, sometimes I think in some cultures they use blood, but like a little bit. And they would infect like a sort of a healthy person. And then that person would get sick, but they would get a very milder form. And the thought was that, you stimulate the immune system with a very small amount of the virus. So remember, that's the race that the body is currently going through, is how fast can the immune system eradicate the virus, and how fast can the virus replicate. So if you have a lot of virus, obviously the virus has a head start, and can wreak havoc. So, having the immune system gain some type of advantage, that helps with like reducing, supposedly, these are all theoretical, supposedly the severity, And so the whole thing about like keeping things clean and washing your hands and wiping things down, these are all ways of like, if you come in contact with it, the viral load will be at least small. These are all ways of keeping it small. Like if you and I are talking and having a conversation, if one of us has it, the viral load that's being transmitted is high. Whereas if we're both wearing masks, even if the virus gets through, it's a lot smaller, which theoretically can reduce your severity of symptoms.
Yeah, so, coming back to the slide that I showed earlier, right? The virus enters the body and it replicates, starts to reproduce. So if you have a high viral load to begin with, right, you're starting with a large number of viral particles. And when those reproduce, right, it reproduces exponentially. So you have a drastic increase in your viral load, and that's directly correlated to your immune response and also your symptoms. And so there was a question about whether we have early retrospective data regarding mutations of the virus. So the answer is yes. And I actually read one of these papers. And so there's one mutation that the NIH is keeping an eye on, and this is a mutation. I can't remember exactly which amino acid, but it actually has been shown to increase sort of the transmission. So what happens is a mutation, it makes this interaction tighter, the interaction of the spike to the ACE2 receptor. And if that interaction is strong, you can have this transmission process continue. So, but beyond that mutation, I don't know, the rate of mutations that SARS-CoV-2 can have. Do they, mutate very fast or slow? I think there's more data coming in about that. But, I heard an interview with Dr. Anthony Fauci, and he also mentioned the mutation, but if I remember correctly, he mentioned that it's at the moment not a big concern. But again, there's a lot of new data coming in. So, and it's a novel virus, so we're learning as we go.
Awesome.
That's the thing about mutations, right? Like even if it's mutated, social distancing, washing your hands, all of those things still work. The name of the game is eradicate the transmission of this virus as much as possible so that it can no longer be transmitted. We're going, people are banking on a vaccine, but the tried and true method is to adhere to all those behaviors. The Spanish flu epidemic of 1918 didn't have a vaccine. They relied on people keeping themselves safe. So if history has anything to do with how this will go, that will be the end of the pandemic, is when we start adhering to those behaviors again.
And I think that, that's a great point, because, all of these mandates that we're seeing now, this is not anything new, right? Like social distancing, you can trace this back to the Bible, right? When you have, people that had leprosy, they had to be shipped to a different island so that they don't affect other people. So there's evidence all the way, in biblical times about social distancing. So, and that's one of the best methods to slow down transmission.
So as someone is asking about, the holidays are coming up and people are flying to go see their relatives, asking what recommendations would you suggest? Still, we suggest masks always. And what else should people know? Like,
So
don't travel.
don't. My
Don't.
first recommendation is don't.
Yeah.
The second recommendation is get tested before you go.
Yeah.
And then the third is allow for some time to gather space. Like if the best you can do is 3-4 days, then try to adhere to those to your mask and social distancing till you can see if you've developed any symptoms. And so that would be my recommendation, because I know telling people not to visit during the holidays is fools. Like they're gonna do it. So try to do it safely, please.
Awesome.
Great advice. We are long by a lot, which is good because it was educational. Nackie and I are we're going to be able to talk about this on our show.
I
That we actually
know.
learned stuff about DNA and receptors and block, all that kind of stuff. We're going to act like we're smarter than we are. What we are going to do, though, we are going to point everybody to the Pacifica Native Solidarity event. And I think they're dropping into the Facebook chat a link to that.
Yes.
Yes, it looks like they are a Zoom link as well.
Yay!
Right. Yay.
So, Nackie, you have some homework. I read at the top that we are going to lengthen Dr. Samoa's bio. And from Facebook, it says, please add to his bio that he has a beautiful sister named Rhoda Samoa. So
There you go.
that will be.
You need to add that to the bio.
Is that from Rhoda Samoa?
Yes. Wow. By the way, yes, it is. So it's awesome. Wow.
Oh, and Carl tried to act like my wife has a genetics degree. Bucky, Carl's wife is a geneticist. She's not,
Basically a scientist.
she is a scientist. She's a
Right.
geneticist,
Hey, hook me up.
right?
Right.
Good. We need more. We need more Pacific Islanders.
Yeah.
research.
Yeah, well, it's great having you guys on, and I hear that somebody may be trying to escape being on the show later. We'll just stick Nia on you, and we won't say any names, but Nia Nia grabs everybody we need. Thank you both so much
Thank you.
for being on
Thank you.
and being patient and teaching not just Nackie and I, but everybody that's
Yes.
listening. And then being that, that role model where people are looking at people that look like them, scientists, doctors, those kind of things, and explaining COVID-19. That's something that we've all, there's a ton of questions are all about, and you guys are answering them. So
Yeah.
thank you for your time. We went way over.
Yes.
So
Thank
hopefully
you
they'll
so much.
invite us back next week.
Thank you so much. We
yeah.
appreciate your time. Join us next
guys.
week. Join us next week. We're here every Monday at 5 p.m. Right here on the PI COVID-19 response team page. We're also on our Facebook page, PCOPSI, PCORI. Go check us out. Primary Island Center of Primary Care Excellence and Patient-Centered Outcome Research Institute. That's who is bringing you all this wonderful information. Thank you again, Dr. Ayang and Dr. Samoa. We will see you next week at 5 p.m.
Thanks, everybody.
Bye.